Hi, in today's video we're going to be looking at reading and writing RAM on the Z80, and also we'll be testing the ROM. Basically we're going to write some code, we're going to simulate it, and then we're going to burn it to a flash ROM and actually run it on some hardware. I'll give you a quick peek at the hardware on the table after I've done the RAM, but we're going to be doing the capture and the logic analyzer in real time over the computer. So I'll be doing that through screen recording, because there isn't going to be very much to see unless you just watch me push the reset button, but I can just tell you I've done that. So without further ado, let's get into it. Here we have a small program. It's designed to test the ROM. Well, it'll test the ROM, because if we see the program running then we'll know it works, and it'll also test the RAM at the same time by writing to it, then reading it back. Now, as you can see here is the memory map of the little system that we're going to be playing with, and the RAM is actually stored at 4000 in hex. It's only a 6116 chip, so it's only 2K, but since when are we going to use more than 2048 bytes in the first couple of tests? The next system may have a full 32K RAM, I don't know. We'll worry about that when it happens. Okay. Now, the assembler, I found a couple of quirks in it. You see these org and forg. Org is to let the assembler know this is where I'm thinking right now, like I'm at 00 hex address. The same here. And forg is file organization, stating that fill nops in the file all the way up to this address. That way it's organized correctly. That way you know where everything's put in memory. I found I had to put both in, otherwise it's telling me that the start address, which is over here at 100 hex, which was at 6 hex, which is not right, because that's before the NMI vector, which is at 66 hex, and that's a hardware vector. I can't change that. Okay, so here we go. It's been told once it's reset, or when it starts at 0, because that's the reset vector, it jumps to start. Also, I was told to do the same thing if the NMI is done. So I could trigger NMI after the system's already started to basically reset the system if I wanted. Well, in effect it's a reset, but anyway. So what we do here is, this is the actual code itself. So we put 33 hex into the accumulator, and then we stick that into address 4010, and 39 to 4011, 4B to 4012. Then we read 4010 back, 4011 back, 4012 back. This I should see on the logic analyzer dump, and then it just loops forever. So we're not getting any spurious signals that we're not interested in. So let's assemble that. See, it assembles nice and quick, and let's have a look at the hex code for this. Now you can see here C3 is a jump, an unconditional jump, and it reads these backwards, so it's 0100, and which is here, and then let's see. Oh yeah, load accumulator with a 33, then store that at 4010, load accumulator with 39, store this at 4011, load accumulator with 4B, store this at 4012, and then this says to load accumulator from 4010, load accumulator from 4011, load accumulator from 4012, and this basically says jump to 0118, which is here, so it will do it forever. And to see that running, I've got a simulator, which I just actually bought this literally 20 minutes ago. It's on sale for €17 from the company. Oshon Soft. Anyway, they got a big bundle on for sale. It's got 4 days left on it, so that's why I bought it. You know, I pirated this program before in the past just to do some testing, so you know, it's only fair I actually pay for it. I couldn't afford it back then, so that's why I did it. Okay, now we'll see in the memory editor here, it's basically the same as what you see here. The reset vector, the interrupt vector there, and here is the code. Now we're going to be playing around with RAM, which starts at 4000 on here, so I want to bring that up on the screen. So 4000. See, in the emulator it's all reset to zeros, but I find in practice sometimes it's 00, FF, 00 repeatedly, you know. Okay, in the simulation, okay, I want to do it step by step, and we're ready to go. Before I start, let's go over a few things. This says the instruction that's just been run, and this one is the instruction that is next to be run, and then it tells you how many clock cycles and stuff is counted. The program counter is where it's executing it from, and these are the registers. So these are the things that we're going to be looking at. Now I'm going to be using the F keys to control the stepping and stuff. So F1 starts it, and F2 will be stepping, or I can click that, but I'll be clicking F2. Okay, so the next instruction to run is going to jump to 100H, or 100X. Okay, so I press the F2, and we jump to 100. And it's fetched this instruction, load A33H, so into the accumulator, go there, and it's going to store at 4010, and we should see it here. There we go, so that works. Load another number, store it there. Load the next number, store it there. And now the next instructions, which are these ones. Get the value from the address and put it in the accumulator. 33 should be 33. That's correct. And then just the next one. Next one should be 39. Yep. And the one after that should be 4B. And then when this says jump to there, then you can see the program counter isn't incrementing anymore. I'm holding my finger down, and it's just, that's all it's doing. It's jumping back over itself. Okay, so next step now is to get this burnt into the well, not burnt, to get flashed into the flash ROM and get it all set up on the hardware. Okay, I loaded up my Mini Pro programmer software, and I currently have the Winbond W29C020C flash ROM in there right now. And this is what I'm using on the board. So we'll open the hex file. Z80 RAM test bin. Yeah, it's loaded in. Okay. So there we go. As you can see, you see here pretty much what you see in the hex file. It's all here, and everything else is all left unprogrammed. And okay, so let's program the chip. Program. Bloop, 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 bloop. Taking a while. Come on. programs the whole chip, so you know it takes a while. Verifying it, and it is done. Okay. So so now it's onto the bench to get this tested, and also set up the logic analyzer. I got the flash ROM in place now in here. I took the 8255 out because it's not going to be used in this circuit. So there's the ROM and the RAM, it's in there, and the logic analyzer is hooked up. But I'm going to be hooking up to the computer in a minute, but I'm going to be doing that through screen recording because basically you won't see anything that's going on here. But I'll let you know when I'm resetting and stuff. But okay. I would love to have done it through the camera, but it just makes no sense because you can't see what's going on. So okay, so back to the computer again. I've now loaded up the logic sniffer. Logic sniffer. That was weird. I've got it all plugged in, and now what I've already done is I've typed in all the labels, which is annoying, but I've got that done. So we've got the clock, the refresh, the memory request and IO request, read, write, reset, and NMI. A lot of people like to look at the M1 line, but I don't really follow it, and I don't have enough space on my logic analyzer to do that anyway. So COM14, yeah, acquisition. Oh, let's do it 20 megahertz. Okay, I want all the channels on. I'm not going to do RLE because it uses the last channel. Last channel's NMI. I don't care about that right now. Okay, triggers. Okay, I'm not going to do any triggering right now either. So anyway, I'm going to plug in the Z80 board, and I'm going to capture and reset at the same time. Let's unplug it. Okay, let's see what we got here. There's a lot of stuff going on. So here's the clock cycles. Actually, I'm going to change the trigger on pin 30. Oh yeah, I've got to do 595. Okay, pin 30 we're going to listen to, and we trigger when that is high. So I'm going to plug that in. Okay, and I'm going to hold the reset button down so we're in low. And it's going to wait, and I'm going to let go. There we go. That doesn't seem right. It seems very bouncy. Okay, after a lot of messing around, I've come to the conclusion that my reset line is very noisy, so I'll have to do something about that. Okay, but I've found out that like at least probably 1/10 of the way through, it actually starts making sense after it's all settled a bit, and I believe this here is where the program starts. See, we're reading from address 00, and we're getting C3. C3, and then 0001, 00, which is good, and the next byte should be 01 at 0002. That's 01. Okay. And then that will jump all the way to the address, was it 0100, so 0100, and where we'll read a 3E, which is a load accumulator with 33, wasn't it? Yes, with 33, and at 32 is to store the accumulator. Where are we? So yeah, 4010. So then that takes us to our first write cycle, which is at 4010 and number 33. And then basically goes for the next one. So our next write cycle, I went through and labelled these, not labelled, put cursors on them so I could see them. But yeah, the line's terribly noisy. I don't know if it's this logic analyzer causing it, or it's just my poor wiring. Maybe both. Why not both? Okay, so at 4011 is 39, which is right, and then we're writing 4012 4B, which is good, and then 4B, okay, and where is it? Okay, the next instruction here, 3A, is a read from memory address 4010. So let's have a look at the address 4010. It's reading 33, which is correct. The next 3A, read from address 4011. So just 4011, it reads 39, which is correct. And then read from 4012, and it does that 4012, it reads 4B. That's correct. And then this says jump and loop around, so this will repeat forever. Now you'll see the differences here. You'll notice it is actually. You'll notice here there's differences as we go along, but that is just the refresh, not the refresh counting. So you'll see they're in line with the refresh, which is one of the biggest pain in the asses from dealing with the Z80. We're using logical analyzer because you get all the refresh ones, but yeah. So anyway, so yeah, that proves that this program is actually running on the hardware, and also proves that my hardware is a little shoddy. So technically we have a very small Z80 computer up and running now. Job done, video's over. No, I'm joking. But I'm hoping for the next episode I will have some Z80 systems set up on a bit of a cleaner piece of board, and we'll be able to execute this code without any glitches like that. It's okay, but I'm happy with that as it is right now. and right now where the software is right now, I'm happy, and until I get the hardware set up, I'm not going to go any further with this. I hope you enjoyed that. It was a pretty good little bit of progress today. Now actually having the Z80 system up and running, but that's not the board I'm going to be using. Good, I just wanted to get some test marks to show that it's actually working. In the next few episodes, I will be transplanting the Z80, well not actually transplanting, I'll be building afresh the Z80 system onto a new board without all that clutter, and then we can start working on some other experiments like getting a screen and input working, and hopefully get an interface to the computer so we can download code without having to sit and flash the chips all the time. But that's for another episode. And anyway, thanks for watching. Please like and subscribe if you haven't already done so. And any tips, suggestions, or any comments, please let me know below. Thanks again. Goodbye.